Right. So today's webinar topic, is about logging. As the subject says, we will look a little bit into ABL logging, or application logging, really, and some tools that Progress provides to help you do that. So about me, my name is Peter Judge. I am a architect at Consulting Work and have been there for about 10 months now. Prior to that, I was working at Progress for almost 20 years, and I worked on a bunch of stuff, HTTP client, web handlers, PaaS migrations, etc. Consulting Work is an IT consulting organization. We focus on OpenEdge and related technology. We're based in the US, the UK, Germany is our head office, and in Romania. Have customers pretty much all around the world. As noted, we focus mainly on OpenEdge technology, but we have skills across the whole Progress suite, from Corticon to WhatsUp Gold to a whole bunch of stuff. Other things that we focus on, or that we have skills in, is kind of this whole shift left thing, DevOps and Docker containers and build infrastructures and all that sort of fun stuff that needs to be done to build good software. So onto the agenda. So what are we going to look at today? Well, kind of what is logging? Why do we do it? And then dive into some details of what I'm calling here the ABL application, or the ABL logging component. In the Progress documentation, it's called the ABL application logging, I believe, and just how to use it, how to extend it, all sorts of fun stuff. Hopefully there'll be some demos that actually work today, but it's always a bit of a gamble, isn't it? So why do we log things? Well, firstly, because we messed up, or somebody else we depend on messed up, right? Something went wrong in the code and we have no clue why, so we put logging in to figure that out. We also need to know when things happened. So we may want to verify that a business process happened, or that things worked the way we expected, that the application started up the way we wanted it to start up, right? So on server startup, did we see, various things load or connect or whatever? And also we need to know if things mess up. So logging captures and records these things at its kind of basic level. Logging usually is a sequential set of events that are usually ordered by time. So as you know, with log files, you can see they come out in the order in which things happened. Not always, but usually. Sometimes they need to be immutable. So if you have an ordered log, you don't really want people deleting things that have happened, because they need to be there for audit purposes. Generally, you want to share the log data. So ASCII text is really common. Most log files are ASCII text or some form of text. Sometimes they get stored in a database. Sometimes they get pushed, the log data gets pushed into some form of a queue, like a Kafka queue or wherever that might be. But generally, because one of its main purposes is diagnostics, it's much easier just to share a snippet of a log file or a whole log file with tech support or customer support organization, and they can read it and give it to the engineers, and it just makes life easier in that format. The other thing that's kind of important is that there's kind of a distinction between these logging events, events of a message or whatever it might be, that are issued on the one hand by an application or by some code, application code, and then they are recorded and managed by a different system or a subsystem or a component. So kind of just separating the here's an event that happened from what am I going to do with it once I receive it. And that becomes a little more important as we go. So events kind of are two blobs of things. One is the data. Here's a message. It says the UK webinar started, and there may be metadata about that. What kind of a message is it? Info, logging levels, info, debug, trace, whatever. When did it happen? Who logged it? And there may be other bits and pieces of metadata around it. And the metadata can be obviously larger than the actual the data that's sent. So in ABL, how do we do this in the 4GL? So in the beginning, we had put and message, and we still have those. to get messages out into a log file. In 10.0a, with the introduction of app servers, came the log manager, which is what many people use, and it's, I'd say, pretty decent. And I'm not trying to, speak poorly of it. It's very good for very many things. It's built into the ABL, so it's always there. There's a log manager handle. You can specify logging stuff from a command line, dash client log with dash log entry types, or in your app server configuration, there is configuration for setting this stuff up. It logs mainly internals of the AVM runtime. So 4GL trace, I'm sure you've all seen. Every line of code that runs, or every procedure, method, not every line of code, but every method, every internal procedure, function, class, program that runs, it tells you what ran, can show you the inputs and the outputs. Dyne objects can help you with memory leaks. When is an object instantiated? When was it deleted? Who deleted it, etc. So all of these kind of internals, largely internals to see. And there's a bunch of, there's ones here. There's some that are kind of debug only. There's one called UBNet, which dumps out some of the network traffic that you really should only use for working with Progress tech support. Logging levels, so how much detail do you want? From 0 really to N, there's no formally defined upper limit. 5 usually gets you a lot of stuff, but I've seen log messages logged at 6, 7, 8, 9 levels. It's just an integer value. But generally, 4 or 5 will get you more than you actually need. And then some log file rollover management stuff. So that's the internals. And you can turn that, you can tweak them as you go, like in the application. So if right now in a piece of code, you want to just see 4GL trace, you can turn it on and turn it off at the end, stuff like that. Really quite useful. You can also write from your application into this log file using the log manager's write message statement. And that is a message, and you can optionally add a group, which appears in the log file. So where you would normally see ABL, you might see my group or whatever it is. So you can choose to put some structure in there. Challenges with the log manager is that it is a one size fits all. It is the log file that you get access to from the AVM. It's one file, it's only a file. So you can't send stuff to a database. You can't send stuff using the log manager to a queue somewhere, not yet. You can't really depend on it always being there, right? The log manager handle is a built-in handle in the ABL, in the 4GL. You can always query it. It always comes back with a value. I'm not quite sure what that is if you look at log manager handle. So the log manager handle is there, but is the log file always there? If you write code that is only ever going to run on an app server, then yes, the log manager will always be there because there's always one of these log files there when you're running in an app server. So that would be the agent log. But if you're running in a different client, a batch client or a GUI client or a TTY client, whatever it might be, you don't know whether it's always there. So you'll end up having to do checks on, is this file here, before you want to write to it. Otherwise, you get an error in your AVM, a runtime error. The other thing is you cannot control the format of the output. It's pretty static. I mean, there's some minor tweaks you can do in PAS, but generally that would be between 11 and 11.7. I don't think there's any way you can change it in the 12 series. So you get what you get. You get the date stamp, you get a process ID, you get a thread ID, you get a session ID, you get a you get what you get. And so that's usually very good, but you may not want that. You may want a JSON log. You may want only certain data to be written out there. You may want it to be particularly formatted with tab delimiters as opposed to spaces or something. So that's a challenge with it. Other things that should be important when we talk about logging, or things to consider, is generally the configuration of the logging should not be the responsibility of the application developer. The developer should just be able to say, write a message, write a log message, right? I don't know where it's going. I don't care. I just know that I wrote a message and somebody should be able to read that. There's somebody who does care about that, who doesn't care about the message itself per se. They just care about where that goes, what levels are enabled. So do we want to see everything? Do we want to see trace, which is going to be reams of data potentially, or do we just want to see errors and warnings, or just errors, right? Where do those messages go? To a file, to a database table, to some kind of a cloud service. I mean, to dev null if you're feeling particularly cruel, but the system admins or the administrators of the application are the ones who determine those levels, right? Generally speaking, you're going to want to use logging as an exception mechanism. So did something go wrong? Yes. How do we find it where it went wrong? Okay, well, let's bump the logging up. Let's see where things happen. I touched on this before. The devs should just be able to write a message simply, right? If log manager log file, blah, 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 then write message is just not complicated, but it's just an extra burden for them to add. We can, of course, add a method somewhere that wraps all of this stuff and use it that way. That works too. But generally, from the application side, you want the writing of log messages to be as simple as possible. And with that, we want as little impact on the system as possible. Like ideally no performance impact, but it's code that runs. So generally we're going to have some performance impact, and we want that to be as low as possible. So given that, and given that log manager isn't always desirable, then what can we use? So in OpenEdge 11.7, I think in 0.0, Progress released a set of classes in the OpenEdge logging namespace. I'm calling it a logging component here, logging framework, some people will call it application logging, I don't know. Logging component is what we're calling it here. And shipped in 11.7, as I said, in this OpenEdge logging courseware. OpenEdge logging namespace, a bunch of classes. So you can use them from class files, you can use them from P-code. It's in that procedure library, which is always on ProPath. So it's just always there. And they were modeled on, or this component was modeled on SLF4J, which is a Java-based framework, the simple logging facade for Java, and which kind of supports a plug-and-play infrastructure for logging in Java. So now we have this. Let us use this. So basically, we have code that looks something like this. My pointer gone. In our namespace, we're just using a using. We define a variable as a logger. So this log writer is our reference. We get a logger. So we're getting one with that particular name. And then we can write stuff, right? Poke started, webinar speaker started at this time. Who's the user? When? Do stuff, right? In code. Obviously, it's not going to be this consecutive in code, but we do stuff. So a couple of things to note here is, firstly, it's interface based, right? Which means that the component and can return you anything really, as long as it meets that interface. The other important thing to note is this logger builder get logger method over here. This will always return you something valid, right? So whether or not there's a logger setup, and we'll look in a bit about how we set loggers up, you'll always get a reference, which means that this later code, this logger info, never has to do a if valid object then, or I suppose in 12.5 and beyond, it can use the Elvis operator, which is a question mark colon, which is a simpler way of saying if valid object. But this was built before then, and it works, in the 11.7 timeframe. So you never want to have if valid object logger then logger blah blah blah. It just makes your code a little messy. In my opinion, it does. So yeah, so we write this message data, and we don't write any of the metadata, right? So we don't have to say at this time we wrote this. We just write the message we want to write. The method names themselves tell you what the level is. So that's a way of doing it. Another way of doing it would be to have a general write message and pass a parameter for the log level. That works as well, but in this case, the method names do that. So info, warning, trace, and these are various levels. So if you get trace, you're going to get everything. If you get debug, you're getting everything but trace, etc. There's kind of a hierarchy. So as I noted, this interface, this iLog writer, that's the logger itself. And it has a couple of important things. Firstly, it has a name. They all have names. And it specifies a logging level. So it's an object instance, and they do, it has a name, a log level. Those named methods are used for writing messages. And the example I showed you has text for that, but under the covers, they use this object called a log message, which you could also pass in, which gives you more control about certain aspects of it, a group, more details or less details. But generally, I'd say 99.9% of the time that I've seen this used, people will just write strings of text, whether it's with a substitute statement or not, but generally just strings of text. There's an additional interface, this iSupport logging, which kind of is a signal for that a class does support logging. So you can, if you're building, factories to build things, you can push a logger in by saying, hey, do you have a logger? Do you support logging? Here's a logger you can use, or it can get its own logger as well. There's various methods for doing that. One of the kind of use cases for the development of this component was to be able to reuse, well, or this piece of it anyway, was to be able to reuse a logger in a web request. So you may have a single logger for a web request, and you want to use it for all the pieces from the web handler to the services that get used to blah, blah, blah. So that's kind of the thought behind this iSupport logging interface. It's not necessary to use loggers. As you saw in the .p, we didn't bother with that. We don't need it. But using the log writer itself, that's the thing. So this is a snippet of that interface. The name and the log level, there's an enumeration, an enum class, or an enum type, sorry, for that. And messages have, a name, a group, or a message and an error. Again, group, message, and with error, kind of in these chunks. So there's multiple versions of info. Why, you might ask, would you want to pass an error into an info message? Well, because you can. It may be useful to pass that in. I don't believe the interface supports passing stop types in, but you could wrap those in an error class or write your own message as well. Not a huge deal. The log message object itself has a couple of things: a group, a message text, and a base text. So the base text is pretty much what was passed in from the developer. So if that's got tokens like curly braces or &1s or whatever's in them, then that is retained in that base text just for informational purposes. And then a formatted message, which gets written out somewhere eventually. There are also some tokens. We will look at those a little later, which are quite handy for a variety of things. So how do we get a logger? We looked a little in that .p snippet. We saw basically there's this class with a static method, the logger builder class with a static get logger method, and we give it a name. And this is a factory method to go and find a logger with that name, or a name that's similar to that, I should say, in its configuration somewhere, and return it to the requester. Either that, or it returns, yeah, well, I'll tell you what it turns in. So it returns basically just a message, or it returns a logger anyway, whether it's configured or not. That kind of dotted notation, and this is also from, I believe it comes from Log4j originally, might just come from SLF, one of the Java logging components, which basically says that dotted notation over here, OpenEdge Net Server Connection Client, that's basic, that namespace we can use as a hierarchy. So on the right here, I've got demo pug talks, demo pug UK, demo, and default. And so we can configure loggers to be broader or narrower. If you think of the logger names kind of matching namespaces in classes. So potentially we could say, well, for all of the OpenEdge.net loggers that we want to get, we could set a logger up of one time, or we could set one specifically for client socket. So for the UK demo pug, we're going to have a particular logger for, but for all demos, we might have another one. So we can kind of configure them, excuse me, however we want to build them. Sorry, we can configure them on that kind of namespace, which can be quite useful. Gives us the opportunity to be very specific or very broad. Also useful to note that type names are a handy way of getting those, but really it's just any string which has got dot delimiters in it. Could be a.b.c.d. The component doesn't care what the name of the thing is. It just knows that it uses that algorithm to figure out what to look. So basically it works from right to left and just says, is there one for the whole thing? Nope, chop it off, chop it off, chop it off. There's a default logger name that you can specify in the logger builder in case you want it always to fall back to that. And then if nothing is found, it does one of two things. It looks if there's a log manager active, and if there isn't one, then it uses what's called the void logger. We'll talk about in a sec. Yeah, so that's the basics of how you would call it, right? Go into my demo code, and basically, hopefully everybody can see that that's large enough to read. And I'm using Visual Studio Code here with the ABL plugin, just because really. So we have that. We can do it old school. Writer. Something that's not useful, right? So we define it, and then we are going to say my log writer equals logger builder. demo.uk.pug.uk, right? That's what I said, something like that. And then we can say a logger is the classic hello world. And so when we run this, this should all just work fine. I'm going to just do F2 is running it. I should just put a message here. What this is, that box, and get its name. And we can and if we run this now, we can see it's got a fatal level, demo pug UK. So we can see there's a logger there. Now, that's somewhat of a trick because in fact, if we just look at the logger, look at the type name of that, and it's an OpenEdge logging logger. I would not expect to see that there normally because we haven't got any configuration in here yet. But in Visual Studio Code, in the plugin, it uses the log manager behind the scenes. As soon as we find out when we build demos, close log, close log. Log. And we'll just unset it. And now if we run this again, hopefully you can read that the logging is off and it's a void logger. So we always get a logger, right? The fact that there's a log manager there was set up as a default just to allow things to work without configuration, just to make it easy to get log data written out without having to futz around with setting one up in particular. You can tweak that. But we always get a logger. Notice here, even when we have no configuration there, this logger doesn't return any errors. It always just calls that without pain. So that is what is good. The alternate way And so, for instance, if we set here, if we remove this, if we look at the log level here and we run this, we can see it's fatal. We can influence things like the log level here, logging level equals 3, something low. If we run this now, our logger that we get back that works is on worn level. So it kind of reads whatever the log manager does. The third way of getting, of configuring a logger is to use a file called the config file, logging.config, and that's a JSON file that lives in ProPath somewhere. I have one set up here, over here. I'll show you what it looks like just briefly. But we have a log file here. And so we could set up in here, what do we call that? Demo.pug, and demo.pug, in fact, so that. I'm just going to cheat and copy and paste. UK. All right, so what we've done here is we're just saying there is a logger named demo.pug, right? Remember that dotted convention we had earlier? And it writes errors, and it uses what's called the full text format, and it writes it to a file named puguk.log. So if we save this now and we run our guy again, what's going to happen is we're going to use that logger. So we should get now a logger. It's error format, right? We said error was the log level, and out it goes to a file called, where did pug.log go? Where did puguk.log go? That's surprising. In theory, it writes it to a file called puguk.log. In practice, it hasn't. Welcome to demos. All right, that's unusual. So we would have expected it to go to that file. We'll get into debugging a little later, but I don't see any debugging messages here. We can debug later. All right. So that was just the basics of how we get one, how we call one, right? So a little more detail about what we can now do. I've talked briefly about that get logger and our login config. So we can say get logger with a logger name, which can be a string like we just saw, character string. It could be a handle. And so kind of if that handle is a procedure handle, it tries to figure out what that namespace looks like from the relative path. So it might be, foo slash, I don't know, account slash GL slash something. And it would say, okay, well, I'm going to look for a logger called accounts.gl something, or a progress line class, right? Because that's a good proxy for that dotted notation. There's a file called login.config, only called login.config. If that exists on ProPath, then the component will read the first one it finds on ProPath and build that configuration from there. So we saw that logger. We've got some stuff in there on filters. Really confused why I didn't write, but anyhow. We'll talk about filters in a sec. And it writes it out to a file called one.log, right, our log. So we can specify where we want it to go. If the file changes on disk, when you ask for a logger, so if you're any logger, right, if you ask for Bob and then you ask for Sue the next time, the get logger call in the bowels of it will say, hang on, did that file change on disk? I know when I last looked at that file, that login config file, did it change on disk? Was the last update time within a certain range? So in the last 60 seconds or in the last 60 minutes, whatever you configure it to be, and rereads that. And so that is really useful because that means that you can change the logging level without having to redeploy any code or redeploy anything or restart anything. Right? As long as whenever the application code asks for a logger, knowing that it's going to check and see what's on disk is useful because you can then say, okay, well, I want to bump up the log level to trace because I'm trying to figure out what's going on. Okay, I figured it out. Let me put it back down to error or warning or something lower. And I now know why it didn't write out, because my log level was error and we only wrote an info out. So that's why that didn't write. But so you can change the log levels and you can change the filters if you want to, and you can change the output destination if you want to, various things. Or you can add a logger if you need to into that configuration file, and it gets picked up at runtime. The other thing that the logger builder does is it caches logger instances and reuses them. So it caches them by name, by the name that you requested, I believe, not the name that's configured here. So if we asked for, so in our example over here, we had logging, where did you go? We had, let's just do debug. And I know my info is going to go. It's configured as demo pug. We asked for demo pug UK. Okay, and now we get our pug message out. Okay, that's better. So things do actually work. And the format over here is defined by the filter. I'll talk about that in a sec as well. So caching happens, so we don't have to recreate, or that the component doesn't have to recreate them all the time. You can build a logger in code if you really want to. This is effectively what happens inside of that get logger message. There's a kind of a factory pattern here. So it's saying, for that named logger, here's a logging level, add some filters, and then return the logger. If you've worked with the HTTP client, this should look quite familiar. Just a fluent API to get that stuff. You shouldn't really need to do this, and you shouldn't really do this in the application code. You may want to do it in some of the extensions we get to at the end. But generally, if you're building the logger in code, the admins can't build the logger in configuration, right? So this kind of conflicts with that principle of developers write to a logger, admins build the logger effectively using the configuration file. So as I say, this is just kind of an illustration of what happens inside. There's a couple of implementations that are shipped by Progress. There's really two. The main thing, well, the first one is sync logger or the void logger, and it does nothing except exist. It's a sad and lonely existence, but all it does is it's basically there to cover the case where there isn't a logger, right? If we can't find one, we still want to return some valid object to the developer who's asked. And so the void logger is just a bunch of empty methods. When you call info on it, it just says, I got nothing to do, and just returns that. The more interesting one is the filter-based logger called logger. Maybe it should have been called filter logger, I don't know. But the logger, and this is a filter-based logger, and it passes a log event down a chain of one or more filters. And the job of filters is to transform or format that message, or append to it, or modify the message, and then also to write log messages out. They work in a particular order. Right? They define it in an order and they run through it in that order. And that is what kind of adds the that's a lot of customization can happen there, but that adds kind of the value to the log messages. So a log event has a bunch of information, right? So what level was the message logged at? Who logged it? When was it logged? Where was it logged? That might be useful to know, like which piece of code, which piece of application logged it, as opposed to an error stack. This would just be like, where did that get logged? Is there an error with it? And then, of course, the message, right? So what level, right? So this is kind of stuff from that method name gets added in here. Timestamp is, self-explanatory. The message itself, we looked at the log message a little earlier, but that would be the text plus tokens plus information about the message, the actual string that gets published or gets written. Is there an error? That can be handy to know, can be handy to use for writing out. Where did the log event happen? Who logged it based on the client principal? That's what that handle is. And then some details, short name and short name format. And those are just handy for optimizations for log names. Filters are the thing that or the things that do the work. The logger itself doesn't actually do all that much. It just takes a message, checks whether it's the right level, and then passes it down the filter chain. The filters are classes that implement this interface, and they just have one method, execute filter, and then they get that log event and they do stuff to it or with it. So there's, as I think I mentioned, they are in a particular order, right? It's got to be as defined. So there's kind of two classes of them, formatters and writers. Sometimes writers are called appenders in other languages or in other frameworks, other components. And these can be mixed or matched. So there's nothing that says an appender or a writer should be the last filter. Probably should be, in all fairness, but there isn't. So there's a bunch of them. We'll go into some of them, from things like anonymized tokens to error to a full text format. An MDC we'll talk about, log manager format. So you could kind of guess that that would write it in the format that the log manager expects. Token context, I'll get into tokens in a bit. And then there's a couple of writers. The void writer, which effectively is a way of turning a filter logger into a void logger, which is a bit silly, but log manager writer, so it knows how to write to a log manager. Named file writer, we saw a little example earlier that just says go to a particular file with a particular name. There's a JSON log writer, you may just want it to write to a JSON blob in a particular format. Message statement writer, if I remember right, just does a message statement. And I think the point of that was to be able to write into a, basically into a log manager log file. But there is a log writer, there is a log manager writer for that. So you can combine these in various ways to format stuff as you want it and to write it out to a variety of places. There's nothing that says you need to have only one writer. So you could potentially write it to disk, you could write it into an HTTP endpoint with a custom writer or something along those lines. So as an example of a formatter or a format filter, a full text format was one we used earlier. And so it kind of gets the event in here. This is just, as I said, just recalculation, but effectively what it does is it takes that logger name and it will format it to this. There's a thing called a token resolver, which we'll talk about in a bit, which does what it says, resolves tokens. And so what the token resolver will do is take that logger name, so demo.pug.uk, and turn it into a short version, into a group. And that just then writes, the formatter says, set the message string to whatever that is, right? The timestamp, when the log was written, when the log was written, the log level in that little square bracket, or at the end here, the message and a message group. So fairly small, fairly simple. Some of these formatters are a little more complex, but most of them are fairly simple things like this. And you can do, a lot of stuff with that. Again, the inputs here, the order of these would depend on the order that they're defined in, but you will process the messages in order. So if somebody changed the message string and you have a dependency on the text, then that may be a problem or maybe an issue, but generally you just get the message, do what you want to it, and pass it on. A writer, this is a snippet of the named file writer. There's some setup in its constructor, but basically it does what it says on the tin, right? Gets that log message. Let's just make sure that there's somewhere to write to. So does the folder exist? Are we allowed to write to that folder? And then writes the message. Puts it in a mem pointer because mem pointers retain trailing spaces and all sorts of things like that, which put unformatted removes very nicely for you, even if it's put unformatted, which surprised me when I saw that first. Yeah, but bog simple, writes it to a file. It doesn't append because otherwise you would just have one message, which isn't very useful. Right, so that's an example of a writer. tokens. I've talked about tokens a couple of times, and tokens are really nifty because they let us put effectively variables in the log messages. So we don't have to, as the developer who's making a call, writing an info message or whatever, we don't have to go and figure everything out ourselves necessarily. We can trust that the component will do that for us. And so tokens kind of take this form: dollar, parens or curly braces, and then a token, which is a group and an arg, right? Something like session. You may have noticed we used session.temp-dir. There could be environment variables, could be a GUID. Timestamps are also very often used. Stuff from the request, message errors, client principals, all sorts of stuff. These tokens are resolved by a class called the token resolver. It's a static class, so it's got a bunch of static methods on it that resolve general strings, resolve individual things, resolve name, resolve time, whatever it might be. A whole bunch of things. You can also plug into that. It's got a pub sub mechanism or a structured event, or strongly typed event. I'm sorry, that's what it's called in the class world. A strongly typed event that you can hook into so you can resolve your own token. So if you've got a token that's specific to your application, you can plug into that and say, I'm going to do something with that. It can be quite handy. So tokens in messages. So before we said, well, webinar started at date now, and we got a client principal, DB client user ID from here. We can change that just to say webinar speaker, client principal user ID started at time now. And those things effectively they resolve to exactly the same thing. Why would you want to do that? Well, then you don't have to necessarily worry about where the stuff came from. It also reads a bit cleaner. And in fact, this demo slide over here shouldn't even need that substitute statement. This won't compile. There's a copy paste error. So we would just say webinar speaker data at this time. So it can be quite handy for resolving that. Can also use them in configuration files. So there's kind of two examples here. We looked at one like this earlier, session tempter. So we can pull off the session system handle. Today, request ID. So we get a request ID if this is a PAS session. Today is today. There's a token format which lets you, is a form of customization. So every line will get formatted this way. So all the messages will have this format applied to them, regardless of if we added another filter format, filter, we would still use this one. So this is just a way of, I suppose, somewhat lazily customizing the output, or simply, maybe is a better word, of customizing the output of each message. So each message, no matter what we wrote, is going to have the ISO date time. It's going to have the message level, right? It's going to have the transport of the request, if you really care about that, if it's web or REST or APSV or whatever, the actual message that the developer wrote, and then the user ID, qualified user ID in that case. So we can do a bunch of things with that. An extension on that is what's called Mapped Diagnostic Context, MDC. And basically, it's a way for the application to, I guess, add their own tokens. So I said there was a publish subscribe mechanism to override tokens. This is another way of doing it. And we can add a token called MDC dot whatever, my name. And when we write the message out, the logging component, assuming the right filter is there, will transform that into that. Easy peasy, right? So obviously you're unlikely to do them sequentially. Like the MDC things might get set at the beginning of a request, and then later on in the processing of a request, you may want to write something like that out. But they're just static for a request, these things, or these MDC values. Data anonymization is also a thing. Sometimes we don't want to write usernames or private things into the log files, but we still want to know who did this, right? I mean, I don't think we would want to write passwords into log files. That would be a poor choice at the best of times. But things like usernames or email addresses or some form of private information, there's a filter for that, the anonymization filter. And what that does is it does a one-way hash of a token value. So it has to be a token value. but it doesn't care what the token value is. It could be, by default, it's set up to do client principal user ID or client principal qualified user ID. So that would be, peter.judge, or it would be peter.judge@consultingwork.com, right? The at would be the qualification. And that uses this C crypt format, which is a dollar delimited value containing the ID, so containing the algorithm. The second item is a salt, which is used to hash. And then the third value is the base64 encoded hash. Right, so that looks something like this. In this case, I've configured my format to use MDC my name, the anon format. And so we have a token called MDC my name, and that gets anonymized to this, right? So this red here, this is 6, this is the algorithm, SHA-512. This kind of bluish color over here, this is the base64 encoded salt value, which is just generated for us. We can provide a salt, but a constant salt, but it doesn't really matter. And then this is the output value. So this is a one-way hash. Why this is useful, so if somebody gets this value, they can't figure, they can tell it's a hash value, they know the crypt format, but they can't go backwards from this to Michael Caine. However, if you know that you've got a value called Michael Caine somewhere, you can go and look in your log files for this value, this 818 LEY, blah, 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 because you know both the algorithm and the salt and the value. So you can go and recalculate the output value. So it allows you to anonymize values in there. Obviously, it is quite long, or the values that get written, but you may not always want to do that, but the ability or the possibility exists for that. All right, so let's go look at some tokens. Again, reading on time. Have a quick look through those. So in my logging config, logging with filters, that would be this guy. So we've got a couple of tokens over here. We can look at this logger called one, which was this guy over here. Oopsie, go away, get. One with tokens. That might be a better one. So one with tokens, we've got a trace logger. We've configured a couple of filters. That Elasticsearch writer we don't really need there. I'll just leave it there. But now there's one called tokens.log is our error message. Full text format, we've defined the format, MDC and tokens, and there's an error format which pretty prints error messages for us. We are going to anonymize MDC my name, and we've got some tokens. So if we go look at our logging with filters, well, we don't want to send to Elasticsearch, we want one with tokens. That would be this logger. So we've got some MDC values, we've got MDC tokens, we've got an error, and so we should see various things in the logs. So if we run this, we're using that logger, and that's dumped into tokens.log. And so how best to show this, maybe top and bottom like that. So we can kind of see our messages. This should be backwards, it's forward still, another message, but a token with a timestamp in it, T now, when I ran it. And then that anonymized name. The other thing over here to note is that the tokens can't be resolved. So who are you is got a question mark value. The token is just written out into the log file. And then our error handler, right? This caught one over here message says, that's the error that was raised, is the call stack it was raised at. So we can kind of pretty print, whether we want it pretty printed or not. If we didn't want to do that, we might just get error caught one, or we could tailor that. So again, the point is that the filters in the box can do a lot, can help you with a bunch of things to write various data out. You can see over here, this was the shortening OW tokens, which was one with tokens, timestamp. We can tweak, that variously. So how do we tweak all of that? That's the fun part. All right, so customizing loggers. So there's a couple of things to do here. So first form of customization is adding and writing your own filters. Right? So you just add a filter, add it into the filter chain to do various things. So we write a filter. So I've written, well, there's 3 down here, reversed words format, translated message format. They may have filter builders. So a builder is the piece of code that knows how to construct that translated message format filter based on configuration, based on something. Right? Could be configuration passed in through this JSON blob. So it kind of knows to take that toLang and turn it into its internals. We'll have a look at that in a bit. Or the URI into something that is known to that filter. Some of them don't need them. Reverse words format, you can guess what that does. And that doesn't really need any config. So filters, builders potentially or optionally, and then add it into, so add it in 2 places. Firstly, at the bottom here into this filter block, which just is the effective definitions. And then we can use it in that config. Translation filter basically says, or reversed words, I've added that filter in here. I'm going to look in this filter chunk with this filter property for what is that type name? What is the class I need to use? Similarly for translation filter, I want to use that. There's the type name. Here's the builder for it. We can also add custom loggers if needed, or build loggers in a particular way. So the logger builder itself has a kind of a plugin design that works on that same named hierarchy that we use to find a logger. You can define a logger builder for those 2. So it gets a little, I'm not going to say inception-y, I suppose is the word I'm looking for. But what we can then do is we can say, well, I want a translation only builder, right? I don't care about any of the other filters. I don't care about anything else. I don't care about config. I just want, if I'm doing translations, I only want 2 things. I want the translated message format, and I want a name file writer to translations only log, right? Boom, and create one. And I can set that in a registry, which is used to figure out what builders to use, called translate. Again, this is maybe an extreme use case, and really coincidentally, yesterday or the day before, I came across a good use case for doing this stuff, not just a demo case like here. So again, we can add filters, we can add custom loggers. So we'll look at that quickly. I think we've got a couple more minutes time, which is good. So the first thing we can do is, let's look at our reverse words format, right? Very simple. It's a filter, implements that interface, and it just flips words around. Where's my config gone? We've got one with reversed words is over here. And so what we've done is we've got a couple of filters in here, but we've added our reversed words filter. That's the class name, added in here. Similarly with the translation filter, and another one called per request writer, which is an example. So if we look at the translation filter, where did you go? Translation. So this basically sends a message to one of Microsoft's translation services. You give it an API key, which is important. You can't have mine. You might see it floating around, but they're private to the subscribers, and that just sends the message and translates it, right? I pointed out there was a builder for this. And so what the builder did was to do something like this. This translated message format has a property of a type OpenEdge net URI, the URI of the service. And what the builder basically does is it says, get that property out of the JSON and pass it as, turn it into a real URI. So that's the kind of thing you would expect to see in a builder. Similarly, we're translating a property called toLang into a JSON property called toLang into an OpenEdge property called to. One cool thing is if the properties are named the same and the type, and they can be, the the types match, so the JSON data type and the progress data type match, there's this filter builder that will do that for you. So API key and region will get taken from here and put into those properties automatically, which is nifty. So we wanted to look at one with the reversed words. Okay, and so how does that all look? What language did we configure to go to, by the way? AF is Afrikaans, just because that's my default. So if we run this now, we get one with reversed words, and that's going to write out a file to backwards.log. And now that is written, and it's still doing it because it's an HTTP thing, but that's now written, done the translation and turned the words around and written them backwards. You'll see Michael Kane here is written in that name because we did not configure the anonymization filter in here, just the MDC filter. So there goes our data, right? So that, I know they're trivial examples. If we don't want to do the backwards stuff, we just take the, in fact, we can just cheat and we can just say, nope, take the reversed ones out. If we run it again, we will now see them forwards, right? So this is my English text translated into Afrikaans or whatever language you want to do. So that's useful in that regard, that we could potentially do this. The one thing you can probably see here is that there is a time lag on that, right? So kind of you've got to balance how much power can you put into this with how long does it take to do it. But for this kind of thing, you could see somebody adding a filter that sends these log messages kind of like Unix T, right? Sends them to disk, but could send them off to a Kafka queue or something like that as well, so that they just get pushed out. That could be handy to do. Obviously, in progress world, you would need 12.5, I think, was the release, the first release with the Kafka stuff. And so that would be good to do there. Excuse me, I also added a example of a write per request writer, and that just lets us say, well, so one of the challenges I find with PAS logs is there's so much in them. Getting all the information for a single request out can be challenging. What this filter can do is it can say, hey, create me a file for the current request, right, which is this request ID in my session tempter. This code is basically just saying, is there actually a request ID or not? And if there is, then just write it to that file name and execute the filter. So this is an example of that. The other thing it can show or shows is using that token resolver. So we subscribe and unsubscribe here in the execute filter method. And the reason for doing that is that in OpenEdge, publish and subscribes hold strong links backwards and forwards. So the publisher holds a strong link to the subscriber, and the subscriber holds a strong link to, or a strong reference to the publisher. And that means garbage collection can't kick in and delete them, and then you'll end up with leaks. So you kind of have to do this. Anyhow, but what this resolver does, it says, well, if the group is request and the arg is ID, which is what we want, then get the current request info from the get the request ID from the current request info and use that as a token value. Oh, and by the way, replace the colons with spaces, because colons may not be good for file names on certain operating systems. So we could just use the request ID and it would get us the colon, the one with colon, but otherwise we can just do that. And that lets us do what we're going to do, right? So we could, in this case, if we run this per request filter, filters, backwards log. So this is, at the moment, as configured, not going to write anything out because I'm running a local session. I don't have a request ID. So I'm just going to cheat or modify this for fun. APSV, isn't it? So we can, again, this is not what we would do normally. And if we run our request again, or our message again, we don't get. Why do we not get that? I would have said we should get that out. Anyhow, interesting. Okay, so that's basic. Sorry, I'm running a little over. That's basically filters. I have an example as well of the logger. So the translation logger builder, kind of the example I showed you. And I can say, well, for, where did that go? Custom logger. So what we're basically saying is for translations, in that group of translations, use that, we should always get back a custom translation. And the way that this is set up is it's going to use that ZU, which is Zulu, to do a translation. We have a log file name, and that is going to put translations only log. So again, we can extend it quite nicely. The last brief thing to look at is troubleshooting. So one of the kind of principles of loggers is that they shouldn't throw errors. You don't want your loggers throwing errors, because that just pollutes everything. You have no idea where an actual error came from. So most of the logger code just does a catch and swallow of whatever those loggers might be. You don't need to have it lying around. But that makes finding failures really, really hard. As I've mentioned a couple of times, you always get a logger back. You might get a void logger, but you always get a logger back. So if there are some issues in the logger builder somewhere, then the void logger is returned. So you get that valid object. There is a custom or a special log called loggerbuilder.log, or if the log manager is running, messages get written into there that say, hey, something went wrong with this logger, take a look at that. And the other thing to know is if one of the filters throws an error, so if, I don't know, if I get an SSL error from my translation logger because I haven't uploaded the certificate, the chain of filters stops there, which is a little annoying, but that's how that works. All right, so kind of the main principle here, or a big takeaway, is to separate the writing and recording of messages, right? Keep the people who write the messages, the developers, they should just write them and not worry about how those are recorded, or where they're recorded, or how many of them are recorded. That kind of belongs to the admins. And the other thing is, you don't really want to have to change some of that stuff because, you don't have to change it in application code and do a redeploy to try and figure this stuff out. When you need to have this on, you need to have it on, and you're going to keep the logging on. And the other thing is, the OpenEdge logging component is really good for this, works well. I think it's got an easy API to work with. Like if you just want to do logging, it's very, very simple to use. I think it's also reasonably simple to extend and customize. You know, the JSON configuration gives you a lot of options there. I think they're quite well documented as well. Should put a link to the documentation in here. And as I said, it's been in the box since 11.7, so it's been around for a while. So it's not just the brand newest. So with that, I will take any questions if anybody has any.